See, this is our question. This is 200 kilo ohms. This is a 5 volt source is added to the base circuit. A 10 volt source is added to the collector circuit. VB is given 0.7 volts. This is VBE. So this is 0.7 volts. That is the saturation voltage, threshold voltage for this PN junction diode. Beta is 100. ICO is 20 nanoamperes. What we have to find? We have to find the base current, collector current, and VCB. That is this voltage. Now, what is ICO? Just a recap. ICO is the reverse saturation current of the collector junction. The equation that defines it is IC is equal to beta IB plus beta plus 1 into ICO. So what we do, if ICO is very much less than IB, we simply write IC is equal to beta IB. Clear? So this is a quick recap. Now let's solve this problem. In this loop, we can say this is minus 5 plus 200 K into IB, okay, plus VBE. See this, minus 5, 200 K into IB plus VBE is equal to 0. And VB is given 0.7. Therefore, 200 K into IB is 5 minus 0.7, that is 4.3. Therefore, IB will be 4.3 by 200 K. K becomes milli here. 10 to the power 3 in the denominator becomes 10 to the power minus 3 in the numerator. That is milliampere. So, we have to find 4.3 by 200. Let's see what's the value. It comes to 0.0215 milliamperes. So we have got our first value. This is IB is equal to 0.0215 milliamperes. Now this is 0.0215 milliamperes, which is much greater than 20 nanoamperes. Because to make this nano, you will have to multiply this by 10 to the power 6, and that will be 21500. That is very much greater than ICO. Therefore, we can say that IC is basically beta into IB, and beta is 100. So 100 into IB means 2.15 milliampere. So we have got our IC. IC is equal to 2.15 milliamperes. We have these two values. Now we have to find VCB. What is VCB? See, in this circuit, KVL, if we apply KVL, this is minus 10 plus IC into 3, that is 3K IC. This resistor into current, voltage drop here, and then plus VCB. See the direction, this is plus minus, so VCB plus VBE is equal to 0. This circuit, minus 10 RC into IC, VCB, VBE. So this is one loop. We have from here what we have, VCB is equal to, see 10 goes plus to this side and this is 0.7, so this becomes 9.3, 10 minus 0.7, 9.3, and this is VCB minus 3K into IC we have 2.15 milliampere, so milli and kilo cancels. This is equal to actually 9.3 into 6.45, see 15 into 345 in this. So we will see 9.3 minus 6.45. So this is equal to 2.85 volts. So our VCB is 2.85 volts. Clear? We have found our answer. Now we have our second question, which is an addition to this one only. See what? Here we have 0 resistance. Now we put a resistor here that is equal to 2 kilo ohms. Now we have to find IB, IC and VCB. When this was short circuit, we found it. These are the results. When we have a resistor here, now what is the difference? The difference is, initially we were doing VB and 0, and this side also this plus this 0. Now we have another voltage drop here. And what is the current? This is IC entering, IB entering, IE is equal to IC plus IB. Clear? So our emitter current is equal to IC plus IB. But IC is what? Beta IB? Beta IB plus IB. So essentially what do we get here? IE is equal to beta plus 1 into IB. That is, beta is 100, so 101 IB. So let's do it again. This is minus 5 plus 200k into IB. Here we have current IB plus VBE, that is 0.7 volts, and plus IC plus IB into 2 kilo ohms. So 2 kilo ohms into IC plus IB, which is equal to this one, beta plus 1, that is 101 IB. Clear? No confusion? We have calculated that this current, emitter current is IC plus IB, but IC is beta IB, so this is beta plus 1 IB, and beta is given 100, so 101 IB, that we have written here. Now let's see, this is equal to 0, therefore this and this is IB, so 200 kilo ohms and 202, this much kilo ohms into IB is equal to 5 minus 0.7, that is 4.3. Therefore IB is equal to, kilo becomes milli this side, so this is 4.3 by 402 milliamperes. Let's see the value. This is equal to 0.0107 milliamperes. Therefore, now our base current is, in this case it is 0.0107 milliamperes. Now we know that IC is basically beta IB, because this is also much greater than ICO. This is beta IB, that is 100 IB. IB is this much, therefore IC is equal to 100 times, so 1.07 milliamperes. See, by addition of a 2 kilo ohms resistor, it is almost half, the current is almost half of both base and collector current. Okay, now third one, VCB. Let's see what is the value of VCB. In this loop, 10 volts plus 3 kilo ohms into IC plus VCB plus VBE plus IC plus IB into 2, that is 101 IB into 2 kilo ohms. Clear? This is equal to 0. Let's say this is equal to, VCB is equal to, from here we get VCB is equal to, see, 10 minus 0.7. So this is 9.3. Clear? VCB is 9.3 minus 3K into IC. You can convert IC and IB also, but we have the value, so we will put it directly. 3K into IC. IC is this 1.07 milli. So milli, this cancels, and here this is minus 101 into 2K. 2K into IB. What is IB? IB is 0.0107 milli. So milli and kilo cancels. Let's multiply this. This is 9.3 minus 1.07 into 3, that is 3.21 minus this value. 101 into 2 into this value. Let's do it. This is 2.16. Therefore, what we get? So we get 3.93 volts. See, initially the collector to base volt was 2.85. Now it has increased to 3.93. But our base current and collector current are almost half of the first value. That is when we had no emitter resistance. Clear? This is the way we solve question. So this is our next question. Beta is given, VB is 0.7 volts. We have to find VCB. We have to find the base current. This is base current, and IB and IC. Now let's see. We can have a KVL like this, minus 5 volts. Then this is, see, this from here to here, this, and then from here to here, and then here. That is, we can say minus 5 volts here. Then instead of getting into this loop, we go through this side. So when we go through this loop, this is 330k into IB. Okay. Then we have VBE. VB is 0.7 volts here. This is 0.7 volts VBE, and then we have IB plus IC into 1 kilo ohms. That is 1 kilo ohms into IB plus IC equal to 0. This is our loop. Let's see. We have 330k IB plus we have, see, IC is what? IC is equal to beta IB. And beta is 100, so this is 100 IB. So IB plus IC is basically what? 101 IB. Clear? So this is 101. So we can write 101 into 1K IB. This is equal to 5 minus 0.7, that is 4.3 volts. So what do we get? We get IB is equal to 4.3 by 330 plus 101, that is 431. Clear? 330 plus 100, 430 and 1, and kilo ohms becomes milliampere here. Clear? So 4.3 by 431. Let's see. 1 by 100, so 0.01 milliampere. Therefore IC is equal to 100 into IB. That is, we get 1 milliampere. IC is 1 milliampere. Clear? Now we have to find VCB. What is VCB? Let's see. See, in this loop, if we go into this loop, what do we get? See, this is, the current is in this direction. So the voltage will be this, and here voltage this. So we can write 330 kilo ohms. 330 kilo ohms into IB plus 2 minus VCB. See, in this we are doing KVL in this loop. So minus VCB minus this current 100 IB into this 1K is equal to 0. Okay. So what do we get? VCB is equal to this 330k minus 100k into IB. So this is basically 230k into IB is what? IB is this one, 0.01 milliampere. So milli and kilo cancels. 230 into 0.1. That is, what is this? This will be by 100. So this is 2.3 volts. Okay. So our VCB is 2.3 volts with this polarity only, plus minus. Clear? We have found the values. This is our next question. See, here we have 12 volt source. This is 2 kilo ohms. Then from here we have this current IB. IB base current is from this point. Let's say this is our C point. That is, we have C at VC equal to this. Okay, at this point. Now VE at this point is given 4 volts and it says VB is negligible. Just to ignore it. Beta is 19. Find the value of RB. What is RB? How we will find? See, if V is this, what is this current? IE. VE minus 0 by 2. Therefore, we have IE is equal to 4 volts by 2 kilo ohms. That is 2 milliampere. So, our this current is 2 milliamperes. Now, if you see this voltage, this current break into two parts, IC and IB, and then this becomes IE. So essentially this current is equal to this current because IB plus IC is IE. See, and this is also IB plus IC. So this is also 2 milliampere. Clear? So when this is 2 milliampere, what will this voltage be? This will be 12 volts minus this drop. That is VC. If we want to find the voltage at VC, this will be 12 volts minus drop across this resistor, that is 2K into 2 milliampere. So K and I'm gone 4. So this is 8 volts. So we have VC equal to plus 8 volts. Clear? Now, if we go by this side, what is this? 8 volts is equal to RB into IB. RB into IB plus this is negligible, so this is the voltage, 2K into IE. And what is IE? IE is given. IE is 2 milliamperes. Clear? Or we could have done this also, that 8 minus 4 is equal to basically RB into IB. We will have the same result. So 8 minus 4, that is IB into RB is equal to 4 volts. Clear? We have this. We have another equation, that is IC is equal to beta into IB. Clear? And beta is what? 19. So this is 19 IB. IC is 19 IB. And this IE is equal to IB plus IC. IE, that is 2 milliamperes. This is equal to IB plus IC. See, this is IB plus IC. IC is this. So this becomes 19 plus 1, that is 20 IB. Clear? From here we get the value of IB. IB is equal to 2 by 20 milliamperes. This is what? 1 by 10, that is 0.1 milliamperes. Clear? So IB is 0.1 milliamperes. Now we will put the value here. RB is equal to 4 by 0.1 milliamperes. 0.1 into this is 40 and milli becomes kilo. So kilo ohms.